Domino is a high-precision performance monitoring and analysis platform for client-side applications. It can monitor and analyze performance issues that occur during the highly complex and rapid iterative process of mobile app development. The client application may introduce new performance overheads with each iteration of new business and new features. Take the application startup scenario as an example. The initialization of newly integrated SDKs and the addition of disk access operations in the main thread will increase the startup time of the application, which will lead to a decrease in user experience. The traditional way of analysis is to perform single-point trace analysis, as shown in the right figure. The business code is very complex, making it difficult to find and attribute problems. This has posed great challenges to the governance of performance issues. Therefore, the Domino platform provides a complete solution. It uses two APK packages before and after code submission, integrates btrace to collect trace data, and performs comparative attribution analysis to find performance problems. It can also recommend performance-enhancing code and introduce RAND in one step for follow-up processing. btrace is an open-source trace collection tool developed by Domino Group with high performance, complete functions, comprehensive data, and ease of use. During app application compilation, trace collection capabilities are integrated, and application and system trace data can be collected during app operation through PC-side scripts. The data is then converted to PB format for structured data storage and transmission. By using PB as the event recording format, we ensure that event data in the recording system is recorded while maintaining the efficiency and scalability of the data. By reducing the file size of the product, we also significantly improve the parsing speed. During app application compilation, Trace automatically inserts automatically generated method IDs at the beginning and end of methods, and keeps a file corresponding to the method ID and method. Compared with inserting trace.begin section and end section at the beginning and end of methods. Because the begin section parameter is a string, inserting 1 million method stubs will cause millions of extra string memory allocations, causing a huge pressure on memory and also causing a huge pressure on data I/O persistence. In addition, the size of string data is unpredictable, and data can only be recorded by using a lock or LFRB method, which cannot achieve efficient concurrent writing of data. Data can only be cached in a buffer, but a too small buffer can easily cause data loss, and a too large one will cause memory waste. By digitizing method IDs, Trace records method execution information into a mapped file. Because the size of method IDs is known, the storage location of data can be calculated by using atomic operations, thus realizing lock-free concurrent writing. At the same time, the memory occupied by method digital storage is smaller, and the pressure on I/O persistence is also smaller. During app operation, method IDs corresponding to methods are recorded, execution time and thread information are saved in memory. By using PC console scripts, the data saved in memory is downloaded to a local file and generates a Perfetto PB format that can be viewed using Perfetto. During the actual operation of Domino tasks, due to memory and CPU occupancy, network response data is not fixed, and random events such as pop-ups and push cause the collected data to fluctuate, affecting confidence. In the running process of the equipment, the memory cache will gradually accumulate, resulting in performance fluctuations when the application is running. And the execution time of the method will also fluctuate, so it is necessary to take active measures to clean up and reduce the occupancy of the equipment memory, so as to improve the stability and data accuracy. CPU will reduce or overclock the frequency according to the load of the equipment, which may still cause great differences in the running environment, similarly causing performance differences when the application is running, and the execution time of the method increases to affect accuracy. Therefore, the Domino platform will clean up the memory and lock the frequency and core of the CPU before the task execution, so as to stabilize the memory and CPU usage. During the task running, it is necessary to control the network variable stability. If the network variable is unstable, it is possible to cause inconsistent responses to the same network request in multiple runs, which will greatly reduce accuracy. Domino platform uses its own network recording and playback tool. By recording the network requests of the test process before testing, when the formal test is performed, the tool will return the recorded network requests, including cookies, token, and other information, and can simulate network latency to ensure that the network request results in each test process are the same, maintaining the stability of the device network. And it supports the serialized playback of specific network traffic. Therefore, during the task execution, the network responses received by base APK and test APK are consistent, which enhances accuracy. During the task testing process, there may be cases where the test application has execution logic differences due to random variables, such as interference from random events such as push messages and pop-up dialog boxes during execution. To address such issues, the platform has sorted out events related to random variables and closed pop-up dialog boxes and push messages through dynamic hook capabilities. This decreases the accuracy problems caused by random variables. By governing the consistency of the above environments, the stability and accuracy of Domino tasks have been greatly improved. Through the above environmental consistency improvements, the problem of significant data fluctuations in the result has been optimized. And the confidence issue caused by network data differences and execution path differences of code branches in the baseline package and test package data has been addressed. Domino trace analysis capability converts both base trace and test trace into trace tree, generates diff tree, and then observes new methods, deleted methods, and shared methods. Then, it can identify which methods belong to the problem of deteriorated duration through wall duration, CPU duration, and changes in lock and I/O consumption. However, the problem of deteriorated duration identified by simply changing the duration may not be an effective one. For example, in actual development, developers may simply modify the method name but not the method body, so although it is reported as a new method, it is a false alarm. To improve the accuracy of trace analysis, the Domino platform has introduced a number of optimization measures, such as through hit rate detection, static analysis, similarity, and LLMs, etc., to improve the confidence and accuracy of the problem of deteriorated duration. We simulate an Android performance issue by adding a lock operation to the main thread of the fragment, which will be very minor and difficult to be discovered in daily development iterations. However, more and more such small time-consuming accumulations will eventually have a negative impact on the user experience. Our platform captures the minor time differences between two versions of the application, including wall duration, CPU duration, and lock, I/O, and so on. Next, I will actually demonstrate it. To save time, we choose a completed task. This is a complete workflow, and you can see the entire execution process and key nodes of our task. We can see that the degraded change point is accurately captured, and the reasons and reference values of performance loss are displayed. And detailed time consumption and stack information are displayed. Also, you can quickly follow up and handle problems on the platform, and smart recommendations will be made for the handlers. This is the introduction of the high-precision performance monitoring and analysis platform of Domino. Thanks. Look forward to receiving your reply.